Hello, and welcome to Burris Agronomy U. This is Matt Montgomery, sales agronomist for Burris. Today's topic, what will the winter do to insect pressure in 2013? Will that mild winter mean more problems? Each year the yield potential of Midwest crops is challenged by pests, and some of those pests are insects. The winter of 2012-2013 has been pretty mild, and that might just lead you to think that lots of insects will plague crops this summer. But is that really the case? Let's start by reminding ourselves how warm the winter really was. We'll begin with Illinois. The top bar represents the sum of the average monthly temperatures between December and February. The bottom bar represents the sum of December to February temperatures in 2012-2013. As you can see, winter temperatures this year were definitely above average in the state of Illinois. Now this is a similar slide for the state of Missouri. Once again, Missouri growers encountered a much warmer winter than is the norm, warmer by almost 10 degrees. But we have to ask ourselves again, does a warm winter necessarily mean more insects? Well, the answer to that question is a little more complicated than saying less than frigid equals lots of bugs. That answer begins by exploring where insects overwinter. And some insects spend the winter down south. If they do, it really doesn't matter how cold it gets in the Midwest because the ones that go south aren't here to be frosted out. Now, other insects, though, spend the winter in the Midwest, and that can change everything. Once again, though, how that impacts insects is a little more complicated than you might think. Do they overwinter in the Midwest underground, under residue, or above ground? If an insect overwinters underground, it may, and often is, buffered from cool temperatures. If an insect overwinters above ground, it will be nailed by Arctic-like temperatures, or it may survive in impressive numbers given a balmy winter. We'll now review the potential for specific insect pests in alfalfa, corn, and beans. Now, alfalfa probably represents the most challenges given a mild winter because alfalfa weevils, clover leaf weevils, and some species of aphids stay here between December and February. In other words, the single digits would reduce their numbers, but a winter dominated with averages that best 30 degrees simply means more of them. Not so with leafhoppers, many species of cutworm and blister beetles. Blister beetles are buffered in the soil, like we talked about earlier, while the other two are south, which we also talked about earlier. Shifting our discussion to corn, we begin to see the benefit of 21st century pest management technology. While European corn borers do overwinter in stalks above ground, the use of Bt corn pretty well keeps that pest in a box that has almost decimated corn borers in the Midwest, and a box that easily picks off surviving stragglers. Don't expect the winter to tell us much about cutworms, though. Remember, they're down along the Gulf right now. Grubs overwinter in the soil in that stage right now, as are rootworm eggs in the soil, and they're buffered from the coldest of winter temperatures, and warm weather therefore really means nothing for these insects. Soybeans are also rather protected from increased insect pressure. A notable exception might be bean leaf beetles. They stay above ground beneath residue, and they will therefore survive in pretty high numbers and will create a problem for the first beans planted in an area. Now, those early beans will be swamped by hungry beetles, but as more beans are planted and emerge, the beetles will distribute themselves more evenly and their yield-reducing potential will be diluted. Remember, early beans are the ones most at risk in 2013. For spider mites, dry in-season weather is a better predictor, not warm winter weather, and soybean aphids really are better predicted by how many fly around in the fall. Let's wrap up by taking a second to talk about that really big headache, Japanese beetles. Japanese beetles overwinter in the soil as a grub. As can be seen in this slide, the grubs go pretty deep in the soil profile. In the opinion of the Burris agronomy team, grubs go deep enough that an incredibly harsh winter would be needed to form the kind of frost layer needed to turn grubs into ice cubes. And if a harsh winter is needed, a warm winter basically means nothing in our opinion. What could reduce Japanese beetles, though? Well, this is a graph of rainfall in Missouri during 2012, and the graph is pretty well mirrored in the state of Illinois. Now notice that some of the most intense drought conditions occurred in proximity to that July to August period. Now notice what stage they synced up with in the Japanese beetle's life cycle. It synced up with the period in which eggs were hatching, releasing young grubs. It just happens that early instar grubs are pretty susceptible to dry conditions. While the winter may not have promoted more Japanese beetles, last year's dry summer may have, just may have, reduced some Japanese beetle pressure. Only time will tell if that favorable scenario proves true. Thanks for watching, and be sure to tune in to Burris Agronomy U for the latest in agronomic information.